In this lecture, we will be focused on the part 2 for chapter 3. Last time we focused on the character and strings, and this time we will get started from the math library. So last time, actually, we worked on the input, output from the console. And input, you can use scanf. Each scanf, you will get a string, and that string actually is a token. So get string, that one is a token. A token is something like X, Y, Z. But you cannot have a space. You cannot have space inside there because it's already over a token. So if you want to get a whole string more than separated, if a string that has a separation with space, and you still want to read that in, you need to use get s. Okay, last time we covered this. So we have several ways of getting the character into the C program. Scanf is one of the methods. And then we have the get s. Get s will get the whole line until it read a \n. Okay, and then you can replace the last one with a \0 to finish it as a string. And then you can also have the get character. So get character get a single character. Get character get a single character, say A. And then get S. Sorry, turn that off. Get S, you get something like A, B, and space C, D, something like that. Scanf. Scanf, you get A, B, but no space in there. Okay, so this one we call it a token. So this one actually is more like a next in Java. You get a single token. This one you get a whole line, so it's like next line. Okay, and this one single character is like next character or something in Java. Okay, so these are 3 different lengths that you can use in C. In C++, it has similar stuff. You have get S, those kind of things, get line, those kind of things. And it's similar. You can study the C++ get functions. Output is using put. And it's similarly, you have put S, put character, and put string. Printf. Printf is like scanf opposite function. So it gets print out by format. And put S is get just write a line to a certain console or something. And put character is print out a single character. So these are the functions we talked about last time. And this week, I try to focus on this math lib. And also, we have another topic that is after math. We talk about the other string-related issues. So now let's get started with math library. And in C language, all of the library you want to include, you need to do include, and then something called like math.h. Okay, so this math.h including the random number and many other things. And it also has a different one for double and different numbers. So math library is not the only library related to math. And if you want to do it in C++, you need to do include, and then you use a bracket. I'm sorry, this one should also be an angle bracket. And then this one, in C++, you need to do angle bracket with C math. Okay, any library in C language, you put a C in front of it, and then don't use .h. You actually will be able to import it in C++. Okay, so that's the rule. Let's make things easier. So now let's look at this math library. C and C++ programming language have a large collection of utility functions built into the language, which you can access by including header file. So actually you include a header file, and the header file actually will search for the library you have in your compiler. And that is a certain library directory. And in the code, using the include preprocessor directive. One of the most useful of these for performing math calculation is the math library. So to access math library in C, you use like include math.h. And then if you want to use those library in C++, you need to include these, but you still need to put a standard library namespace. Remember when you do string.h in C++, you also do string. You also include string, but you still need to do std using the namespace std. Otherwise, you cannot use that. Okay, so that's what it is in C++. So those are actually done by preprocessor, means it's not by compiler. It's actually before you actually compile the code, they will replace those code from the library. Is that okay so far, Eric? Hello?
Yeah.
Now let's just get out of these before we go into the next program. Let's go to our program, okay? So say I have these C++ programs and I want to go to dev C++. Okay, that's the version we use, right? And then we go to this min GW64. That one is the GCC compiler we use. And here you can see include, okay? And you can see like and GCC. Okay, right here you can see different library. Okay, right here, there's a bunch of the code right here. There's a bunch of code right here, and then let's look at it. Here is the float.h, okay? And then let me see. Here, this one is the float.h. Let's open this float.h. So this float.h actually is the, when you include the float.h, it actually is calling this one. And when you use the standard library angle bracket float.h, it actually will get this file. And all the floating point definition is over here. Okay, and then when you call C float, same thing, you will get this same file. Is that okay?
Yeah.
So actually, when you call that angle bracket, the angle bracket actually go to a standard site to get those definition file. And those definition file actually also written by people. Some people like this one, GCC version, it will go to here. Okay, it will go to here. And some of them, like, okay, you can look down right here. It has standard something, STD something. Here, he has a lot of different things you normally call. It's here. And there are something special like standard lib C++ or something. Okay. So here is actually the installation. When you ever use a C++ library, it's actually over here. The min GW has a whole thing that usually you include it. Will go to here. And this one also has the ASCII something. So here may have different directory, but the whole purpose, this one probably for C. This one probably for C, and then let me see. Let me move down to the M part. So many files. So that's why he said that C++ has a huge library. So the math.h is over here, okay? This one's the math.h. So this one's the h file, .h file for for this one that H file for C language. So here, say pi is like this. So if you use the constant mass underline pi, is actually something like this. Mass underline e is something like this. Okay. So here you have a sine cosine function. You don't define in here. Is that okay? So basically, whatever you have an include file, it actually come to here. You know why I mentioned this? Because if you go to the system programming, say your course, ICS 53, you need to go into the system level programming. You need to know about where are your include library, and sometimes you need to put a include library for yourself. So that's why you need to be aware that when you compile certain code and not put into a certain directory and not need to be made available for other programs. So that's why I spend time to discuss that. Okay, let's go back to here. Now the next one. Right here, we are at the math library. And then the next one is this polynomial function. We actually, let's read this first. This one actually include stdio, that's the console IO. std library that actually has many different default libraries. So this one actually is for scanf, printf. They all come from standard IO. And then you have file, operation, and math. Math is the mathematical library. Okay, these libraries are very essential. And sometimes if you don't find a certain function, you just search from internet, Google it, you will actually find it. Okay, now let's look at this program. So this program, let's look at the main function. The main function actually, it will open a file called poly.txt. This one W is for writing. Okay, and it create a file handler, and this file handler, remember, is actually a pointer. It is a pointer, so it actually FP actually pointing to some file handler with a lot of file information, and that file information go to disk, something like that. So your poly.txt file is here, and then use that file handler to hook it up. So you open the file, you open the FP file, right, poly.txt, and then you try to write something to it. So you printf means printing to file. Which file? This pointer will show you that file. Okay, so you put something like that, and then you print something to the file again with all the x values. So x is coming from 0 to 2.01. So actually it's something like print out some x value from 0 to 2.01. And then after that, you print out the polynomial function for with that value x and the coefficient array c. So it actually would get some function like this and put that out, print out those y function get from that polynomial function. Now let's go back to the polynomial function. Let's go back to the polynomial function. So what is a polynomial function? Right here, you have an x and some coefficient. So this coefficient is a certain array. Say I have 1 minus 2, 1. This one actually means this one is an array. So that array actually represent what? Represent this. So it actually is like this one, x squared plus minus 2x plus this one, 1. So A0 for the coefficient of 0 order, A1 for the first order, that's minus 2, something like that. So you keep doing, well, whenever you got an x and the coefficient array, you raise up the power for x and then you time the coefficient, and you have this running sum, you will calculate the value for this polynomial value for you. Is that okay so far? Hello, Eric?
Yes.
Is that okay so far?
Yeah.
So this one is the way to calculate a some this one actually help to calculate something called f of x for a certain point x. If you have a point x, this one is trying to calculate f of x. And since you run all the x over, it will give you a lot of point for f of x. Okay, and we
Wait, what's SSYS file .h for? The include?
That actually give you, yeah, that include actually give you what? Give you the file handler. Give you this file handler option. So f open is by that. In C language, you use this f open. Okay, so you need to have that sys underline file. So remember this is very useful. Whenever you deal with file in C, it's like this. What is in C++?
I don't know.
C++ F string. Remember that?
Oh.
Right? So these two are equivalent function. But this one is in C++, this one is C. Is that okay? So yeah. This one actually, if when you open something like F string or F input string equals something open like some file, right? FP something file name, something like that. And FP dot open something. Remember that? You remember that one?
Yeah.
Now let's go to there. Okay, let's go to C++ review that one. Okay, since we bring this up, and I want you to really understand both language. So let's go to there. Make sure, because we are doing cross training, I want you to be able to handle both language. So here we probably is chapter 3 or 4. Let's try 4. Yeah, this one is it. Okay. So basically here it has some math as well. So let's see the file of IO. Let me try to get some file IO one. This one is actually not the file IO. Let me try. Oh, okay, other IO string. Let me see. This one is still the standard IO. I need a file IO, sorry. Let me actually pull that more. This one is still string IO strings. Okay, here we have the file. Okay. Now, so to use the file, again, in C++, you use the file string, right? So remember that you have IO string, that's for your console. So that's your screen and monitor, right? Your screen monitor and your keyboard. That's called standard IO. That's an IO string. And for file, you have the F string. For string, it's string. Remember that? So you with the string like out, you can actually put that string to put into a certain string, and then string that string, you can do those to string function. Remember that? So that's the kind of things like to handle different kind of string in C++. And here we use for file, we use the F string, right? And then right here, so you include that F string, and then you put a input file string my file, and my file open with that file name, right? Something like that. That's the way you do it in C++. And for writing out, you use the output string and something like that. So in C++, there is no W, no write or read a flag. No, it's actually using the F string IF string or output string. And then you need to close those two strings. Okay, let's compare this with the C language. With the C language, it's actually different. C language, what it did actually is using the same F open, but it actually has this W mark for writing. You put R for reading. So this one for writing, but and also it has a pointer right here. And apparently in C double plus is only a reference, it's not a pointer. Okay. So these are two things you need to remember. So one thing is that if you go to my file, always it's in chapter 4 for C double plus, and chapter 3 in C. So when you need some file or some example, you go to the class right here. Okay. My course for C is right here, this course, C double plus this course, chapter 3 or chapter 4, this is chapter 3, this one chapter 4, for the IO file examples, all the program will show up. Okay, so these are the different file handler for different language. Okay, now let's focus on this C part. So this C part actually we actually try. The first one is like I print out a whole bunch of the X points. I print out a whole bunch of Y points. So some X value, some Y value, and these two set of value is used for X and Y. And Y is a polynomial, and that polynomial is x squared minus 2x plus 1. And then I try to get the differential different. I take d, f, d, x for it. Okay, that's the differential function for it, and I print that out as well. And here, the differential function is right here. You take in y and yh. Yh is like, you take the y and yh. Okay, it's a double y and yh. So it actually is diff. So you actually take in this so-called YH is f of x plus h, something like that. Okay, and the number of steps. So with that, we calculate the differential delta f over delta x. You know, with this whole function is trying to do this. So it will give you the f prime of x for a certain x value. That's the whole purpose. Is that okay?
Mm-hmm.
So this function will, so basically this function gives you the f prime of x function. So here actually you calculate the y value and y h value, you know, with a small step, right? X and x small step, and then you calculate the delta f over delta x. Okay, that is your f prime of x. So with that three data, we actually plug into here. The first line is the 0 value, x value. The second line is the y value. This one is dy dx, and with that we plot. This one is actually, so this one, blue one is x squared minus 2x plus 1. Red one is 2x minus 2. So actually it's x minus 1. Okay? It's something like that. The line, the differential line. Okay, now let's go to the program to see how it works. Let's go to the program to see how it works. So go back to C program. So go to C tab, chapter 3, poly. Okay, right here, I open with the notepad double plus. So here is the program. Okay, define the number of coefficients, 3 coefficients. So the function is as what I described. And then we actually will use this one window R, print this. Okay, and then do cd space, left mouse click, right mouse click, copy, put here, change to that directory, dir, we have this, and then we build, right? And then we run poly. After we run poly, we will have the poly text. So it will give you this, right? Give you a whole series of the x function, and then you give you a whole x value, and then they give you a whole series of y value, and then give you a whole series of f prime of x value. After that, you open a, I don't want to open this one, that's already done. You open a new Excel file, let's call it TT, open that one. Okay. And then in our poly, we know this one, I copy the whole thing up to for x. For x, let me copy this value for x. And put right here for x, okay? So x are right here, right? And then I actually bring this up for the y portion, that is, you can also use Python or Pylab to do this. Then
Something similar.
I just try to give you idea of how I use it in Excel. Okay, and then copy. Well, here these are numerical calculation. I think Python is better, but anyway, after you finish this, the whole thing right here, you actually do insert chart, and then this one, click, it will give you this chart, okay? I'll give you this chart, okay? Okay, I just show you how I did it. I don't want to save, okay? Close. That one is a polynomial function. So use a mathematical function to create a polynomial function, and you actually remember that in Java, I also teach you how to do integration and derivative, right? So here is the function, you get the poly.c, you GCC, you have the execution file, it generates poly.txt, and you send it to Excel. That's the whole process of doing the math over there. And inside here, we actually do include the math library, okay? And then that's build and get that part is okay. So here are some standard functions. If you include from math.live, you can have all the sine function, cosine function, tangent, cotangent function, and this hyperbolic function, sine, since, cos, okay? Since cos function, hyperbolic function. Cosine function is a square, a square plus b square squared, right? And hyperbolic function is like, a over a square minus b squared, something like that, okay? There is something called hyperbolic function. You can check the equation. And then here you have, in the math function, you also have this different mathematical function. Exponential is easy, f exponential, log 10. This log is natural log. Log 10 is like common log. I use a 10 base log. Okay, so that's something you can. So before you actually use that, you should go to like some where to get this definition for this function. So these are actually useful. If you come back to get the slides for this, you can always find out these different definition for the math function and see them for math function, those kind of things. Remainder, okay, maximum, minimum for something. There are a lot of mathematical function, okay. And then this is for mathematical function, but remember that float or integer, There are two library you may need to have also. Not only the math.h, there are something you also need to have, like flow.h. When you need to do, there's a flow.h. Okay, flow.h actually is, there are something like maximum 14-point number, minimum 14-point number. You need to go here to get the flow.h. Something like some constant, that's the maximum or minimum four number. When you do sorting or you do finding maximum, if you need that one, and maximum double value, you know, those kind of value you may need. When you use that maximum or minimum 14 or double value, okay, that's a flow.h, and also there is something called int.h, I think. Standard integer.h, I mean, sorry. So this standard integer, as a standard integer.h. It also had a different type that we mentioned before, and also the integer maximum, integer minimum things. Okay. So that's the, not only the math.h, you also have a standard integer.h and also have the flow.h. These are commonly used for math. Now the next one is the more important thing called random number generator. For random number generator, you need the following include file: time.h, std live.h, std int.h. Okay. Well, what is the time.h do?
It has time.h.
Yeah.
It has like a it's a library with like, there's like a stopwatch so you can count the time and stuff.
Yeah. You can use it as a stopwatch, and you also can get a system time.
Yeah, system time.
Okay, and what does system time represent in time.h? It's actually a time in ticks, and one tick is actually 1 millisecond. And since the year 1970, January 1st, right?
Yeah.
Remember that one? Okay, good. At least you know this part. That's good. That means you really understand something. Okay, so that actually is that. And then there's a constant called rand underline max. That means the maximum random number you can have. And there is a seed function. You have a long integer set random seed. Set random seed. You set a seed with certain seed. Okay. And then there's a random function. This random function, you will generate a random number from here to here. So it's actually returning integer. It's different from the math.random in Java. That one is getting double type value, right? Here it actually returns set rand actually return integers. But the maximum number you will get is this. So if you do this like rand converted to double, right, divided by rand underline max, it is equivalent to what? This one is equivalent to math.random. Is that okay?
Yeah.
It is equivalent to that. Oh, actually, the division is rand underline max plus 1 because you cannot equal to that one. Okay? That will give you 1. Is that okay? You need a plus 1 for that. Okay, next. So here I have a custom design function random.c. This one actually very useful. This one, the whole thing I'm discussing here for random is very useful. Let's go to the code directly, okay? I don't want to waste time over here for the slices. Let's go to the random, okay? The random here, I have several files. Let's read the .h file first. So .h file here, I had a reset random, 01, random 1, random int, random integer. These are something that I wrote, but it is actually very useful. So let's get this random.c as well. So we have .h file, we also have .c file. Let's compare. So this one actually we bring in the random.h, and here you have used the standard IO, standard library, standard integer, and standard time. Okay, we can reset a random number generator, and I use time with null. Null actually is 0, so I use that to reset the random number generator. Okay, I use that to reset a random number generator. Use a certain seed, and then as I say, this random function. Why I write this random function? Because I want to have a random function similar to mass.random. Okay, so I write this random number. It actually is a double range divided by double random max plus 1. So this function is exactly the random function that will give you this from 0 to 1, but not including 1. Okay, so this actually is very useful. You can copy this to you. It's just like that toString you use. Okay, very useful. Every time you want a random number, it has the same definition like Java. Is that okay?
Yeah.
So this file actually, you can random.c and random.h, you can always include that in your system. Okay, so that one give you random, and then random 1, it actually this one will give you a random number that including 1. So this random 1 slightly different from the random, but it allow you to include 1. Sometimes you need that. Sometimes you do need that. So I give you a random 1 function as well. Sometimes you do want to have a boundary. So that give you something like that. Okay, and then here we have random int. So this one is like use random times max, and then that give you the random integer, and you convert it to integer. So if you read this, you just think about here is an unsigned integer, 32-bit unsigned integer, and then you actually, this one is the count. Remember that I talked about mass.random times count times, and this one take integer, right? And then times steps plus baseline. You remember this equation that I teach in AP course? You still remember this one? Now
Yes.
let's review this one, okay? Let's review this one. Okay, right here. Okay, that one is actually for this. You have a random number generator. We have 3 number, and that 3 number is used for this random number generator, base, step, and count. Okay. So, for example, I would like to generate some number for a die, right? For a die. So I started from random. This one will create something called 0 to 1, right? And then I have a random times count. And this count I set to 6. This one should generate 0 to 6, but not including 6, right? And then the next one, I have the integer quantization, random times count. I quantize with the integer. This one create 0, 1, 2, 3, 4, 5, but no 6, right? And then I have an integer random times count times plus 1. This one give you 1, 2, 3, 4, 5, 6, right? So this one we call it base. This one we call it base. This one we call number of elements. So we use count, the number of count. So totally 6 counts, 1, 2, 3, 4, 5, 6. Starting point is 0, we call it base. Is that okay? Hello?
Yeah.
So if we want to generate 2, 4, 6, 8, 10, 12, it will be the mass random times 6, and then quantize with integer, and then actually times 2 plus 2. Starting from 2, each one separated by 2, that we call it step. And then totally 6 counts. So that will give you this sequence. Okay, that's the equation I use. That's the equation I use, baseline, step, and count. This equation is random times count. Take quantization times steps plus baseline. So baseline is the lowest number 2, right? And then each one separated by 2. That number is steps. So the next one is 4. And total 6 of them, you get this. Okay? So that actually is the equation here. Now let's look at this example. This example that we need to generate a number that's starting from 11, separated by 2, totally 10 count. So that actually will generate a number, the first one 11, separated by 2, it will have 13, then 15, 17, 19, 21, 23, 25, 27, 29, totally 10 counts. So it will be something like this. Okay? And that function I put into this one called random integer. Give you a systematical way of generating random integer. And that function is right here. It has the random integer. Not this one. It has a random integer. This one, random integer. Random times count. Take quantization times steps plus the baseline. Okay? And I told this in AP Computer Science as well. And then here has a main function to test it. So that one has this. Let's go to run it. So right here, let me use this window R, window this, and then CD. Left mouse click, right mouse click, copy. Go back to here. Right mouse click. Okay, I'm sorry. Here I should put a space between them. To the end, return, dir, build, wait, something wrong. And reference the, oh, I do not turn down the main function. So here, let me see. I'm sorry. I did not turn on the main function. So I need to open this. And then I open this random.h. So here, because I usually put it for other people to use it. So I do not set the debug. So if I don't set the debug, my main function is not there. Is that okay? Hello?
Yeah.
So my debug is only when I want to debug my function. It's useful. Otherwise, this file is just like normal file for people to include. So right here, I need to put it in debug mode so that my main function is turned on. If my main function is turned on, then I can compile my own code for testing purpose. No, not this one.
Mm.
You know what I'm saying? That's the way I manage that module to have a testing mechanism, but also when actually you know what I'm saying? So here I generate some random numbers. So first one, random fraction. Each one I use a random number that's between 0 and 1. Okay, that one is between 0 and 1. So I have several function random number between 0 and 1. Second one, random integer, that's positive integer with the maximum value of 10. So it actually from 0 to 9. Okay. Third one, I put random number generator. Baseline -5 for the minimum is -5. And step is 1. So it's come from -5 to and totally 11 counts. So it's like -5, -4, -3, -2, -1, up to 5. So it's actually -1 to -5 to +5. Okay, so ±5. Is that okay?
Mm-hmm.
Okay, so this one. So another way of doing this is like if I comment this out, then I lost my main function. And it's good. It's good I lost my main function because then this module will become something other people can include without the main function. Is that okay? Is that okay? This is a programming skill. So I can set this one, just use it as a library now. So some other people can. Normally I put it off, unless that I need to debug my own module. Okay, that's the use of the standard a library if you want to debug it yourself. If you roll some library and later some people want to use. So here like formatted output printf. Printf is similar to the printf you have in Java. And here we have scanf and printf. Scanf is taking token in, similar to the next function in Java. Okay, printf is like printf in in Java. So nothing really special. Actually, scanf can be like next integer, next stop, all those kind of things. So printf, we have similar stuff. So that's just pass it. So input output flag, you know, right here. But the only thing that in C languages, printf, the only thing is that they don't support %b for binary. Okay, that's one thing you need to think about it, how to do it by yourself. It doesn't support a binary format output. Other than that, your character output, integer output is all the same. All the same with Unicode output, or these are all similar to Python. I'm sorry, the Python and Java. Okay, and in scanf, you always need to put a sign. Why? Oh, here need to have double quote. I'm sorry. This one actually is a typo. I forget to put a double for the format. This won't work. Okay. Let me actually change it on site. Why I need to have a S sign over there? Anyway, why I need to have an S sign over there? Why I need to have an S sign over there for the console input? Console input. Why this A need to have an S sign? Address sign.
The address, not the body.
Yeah. So actually, it's like
if you just give the body, you're not giving the location for it to store the thing.
Yeah, it's actually like integer, and then you will have a star X something. So this one need to use address to there. Okay. So it's a pass by reference in order to modify the variable. If you don't have that, you cannot modify the variable. In C, you need to escalate one level up, right? So that's that. And here we have several different formatter. for your input. So scan function scanf somewhat like next integer, like next double. You know what? When you specify the s, that one is next. When you specify percentage d, that become a next integer. Is that okay?
Mm-hmm.
So scanf actually is a programmable next function. You just think it that way, it will be easier. But you need to put the h's in there. That would make things easier for you to understand. Okay, and then here a lot of detail, you just go through by yourself. So right here we have a program. A character equals a string like this, floating point like this, and then I print out with different format. Okay, so this one actually pretty straightforward and simple. I don't want to waste my time over it. So here we have a keyboard input scanf, and this one percentage d. So this one actually become a next integer, like a function. Okay, so that's that. And then this one like the next character. Okay, and for character you always put a space between this and that, this and the percentage. That is something you need to be careful. If you want to do single character, always put a space. When other format you don't need that, just the character. Okay, just the character. Is that okay?
Mm-hmm.
Remember that just the character. Just the character, you need to put a space in there. Okay, and then integer, flows, long, double flow, not for double type. Okay, these are okay. So this is next double, is the next floor, is the next integer. So you can always come back to here to study which one you won't have. Escape sequence is same as the Java and Python. So there is nothing special. Backslash A, backslash B, backslash F, backslash N, backslash R. These kind of things are similar. Okay, it's used for output formatting. So this one, you have the number 50, you print out this, you try to get character. This one get CH and get CHAR is different. This one get a key code. This one get a key code, so it actually is not getting a character in. You just get a key code, you can print that out. And it also used as a stopper for your program.
Mm-hmm.
Let's try this one, okay? Escape.c. I want to show you this, okay? Get character, get CH is actually really commonly used. Okay, I don't want to compile again, I just do it. Okay, here is stop, right? I print out something because that program actually keep going, right? I want to hit a key until before I finish my program. So that right now the whole program, you print out something, whatever backline, that part is good, right? But here we have a get CH, so the whole program hold up right here, waiting for an input of a character. And here, right here, I hit a space and you finish. Is that okay?
Mm-hmm.
And then as you see that it says that the key code is 32. 32 is the space. So for example, if I do it again, right? And right here I hit Shift A, it gets 65 because it's capital A. Is that okay?
Mm-hmm.
So that one actually will stop and waiting for you to put into a character. So this part, today we finish the math library, random library. So always come to get the code for the random library because it's quite useful. It will make your environment more like Java, easier for you to use. Okay, that one. So make sure that you download that file. I'm sorry. So it actually is under my C course. C chapter 3. Remember, there is a random. Okay, here are a few good library, and you just go to my course. Just go to my course, and in C course, you have the enrollment, and then go to the chapter 3. Oh, I haven't put it up there yet. Oh, right here. I'm sorry. Chapter 3. I'm sorry. Chapter 3, this part, I would continue to put it in. Wait, how come it doesn't go? Okay, here has the chapter 3.zip. Okay, the chapter 3, download that to get those code. Okay, that's it for this section. Thank you. Bye now.
Bye.